G'day, I'm Ross. Understanding the airflow around a rotor helps in discussing the changes that occur in lift and drag with different stages of your multi-rotor's flight. The concept is quite easy. During the flight, there is a lower pressure region on top of the multi-rotor blade and a higher pressure region below the multi-rotor blade. Airflow naturally wants to travel from an area of higher pressure to an area of lower pressure. The pressure differential creates vortices, known as induced drag. The larger the vortices, the more induced flow through the rotor. Now that we understand the airflow around the rotor blade, there are different stages of flight where this airflow is affected. Close to the ground, some of the airflow hits the ground and doesn't get the opportunity to recirculate, resulting in less induced drag. In turn, the induced flow is less, resulting in an increase in angle of attack. Therefore, close to the ground, less power is required, especially over hard surfaces. This is known as ground effect and occurs within approximately 1 blade diameter from the surface below. As a multi-rotor climbs out of ground effect, in the hover, airflow recirculates through the rotor, resulting in larger vortices and more induced flow. The larger the amount of induced flow, the less angle of attack for any given blade angle. Therefore, a multi-rotor is least efficient in the hover. As a multi-rotor aircraft transitions to forward flight, it begins to accelerate away from the vortices, which no longer recirculate through the rotor. As the aircraft accelerates, the induced drag reduces, resulting in less induced flow. Lift is greatly improved by the airflow, naturally increasing the angle of attack. For aircraft not utilizing height hold, the aircraft appears to naturally climb as the aircraft accelerates in forward flight. This increase in lift is known as translational lift. I hope this has helped you understand airflow around a multi-rotor and the subsequent changes during ground effect and translational lift. Thanks for watching. See you next time.